So welcome and good morning. This is going to be a great hour for us and a great hour for you, I think. We are broadcasting from Boulder, Colorado, University of Colorado in Boulder, and this is a webinar on the Lockheed Martin Engineering Management Program, and we are happy to be here to present to you. I recognize that many of you who are watching today are joining us because you'd like to maybe consider your next educational step, your next step in education, and also whether engineering management is the path that you want to take. And if you're to that point, then maybe you're wondering whether the University of Colorado program is a place that you want to go. So that's what this webinar is about. It's designed to answer some of those questions. And speaking of questions, should you have any during our presentation today, please type them in. You should have the capability in the software, I believe it's Zoom that we're using. You should have the capability in the software to type in your questions. And I know, having been a student a good while in my life, if you're watching a webinar or in class, the worst thing in the world is keeping the question to yourself until the end. So please don't do that. Please go ahead and type it in. We have several people here in the studio with us, and they'll be happy to relay your question to me or whoever's speaking, and we can address it right away. So please don't hesitate to do that. So it is a beautiful day here in Boulder, Colorado. I know we have some guests joining us from the East Coast, and we here in sunny Boulder feel very sorry for you because you may be wrestling with a, what do they call it? A bomb cyclone? Give me a break. It is going to be 60 degrees and sunny here in Boulder, Colorado. We're tucked in next to the foothills. It's a beautiful place to be. Those of us who are able to attend class here and teach here feel very lucky that we're here. But wherever you're at, that's great. So we have a few people presenting today. Introductions here. We'll take care of those now. So I'm joined today for our presentation by Professor Wendy Bailey, who leads our quality sciences area. And by the way, I'll just tell you this up front. If I were to be going through this program, given the power of quality sciences and its importance in business and industry and government, I would sign up for that. I got to tell you, it is an incredibly powerful vehicle by which business and industry manage their operations. And so she's going to speak with you a little bit later. You've got me for about 10 minutes. I'm going to provide a quick overview of the engineering management program, and then I will be followed by Wendy, Professor Bailey, who will provide a short presentation on quality sciences. And the purpose of that is to give you a taste of at least one of the study areas that we have in our program, and also the quality of instruction, since Wendy is one of our best teachers. And we're happy to have her as a member of our program. Also in the studio, we have Ms. Lou Rutherford, who is our Associate Director and runs our program. Also, Ms. Kendra Tebow, who is our Graduate Admissions person and also our Graduate Advisor. So those of you who may find yourself after this presentation thinking, yeah, this is what I want to do. So if so, Kendra's information will be up on the screen a little bit later in the presentation. Also joined by Ms. Amy Viverito, who is our outstanding and amazing marketing manager who set this webinar up, and thank you, Amy, for that. So the agenda goes like this. As I said before, about 10 minutes with me for an overview, and then I'll turn it over to Wendy to speak to quality management. And so our purpose here, as I said, is an introduction to the engineering management program. This program is an incredible vehicle for learning. Many of our graduates write back to us that this was not only an educational experience, it was a life-changing experience in many ways, not only professionally but personally. Our teachers, our faculty members have both industry experience and a depth of educational experience. The idea is that in the classroom, when you're with us, you're getting 50% theory, but also 50% application so that you can take what you learn and put it to use right away. For those of you who work in business and industry and in government, or perhaps not in one of those areas, but you're interested in management skills, I have to tell you from personal experience that this is the place to be. So we're happy that you're here with us, and so that you have a chance to learn a little bit more about what this is all about. We are part of the College of Engineering and Applied Science, and that's just what the building looks like, and it is just that kind of day outside, blue skies. We have our home in the tower that you see there in the middle of the complex. The engineering college has been here for a very long time, but I would tell you that nowadays many of our programs and departments are ranked in the top 10 in the nation. We're proud to be part of that team. Out of the thousands of colleges and universities across the nation, to be ranked in the top 10 is significant. And so that's a testament to the quality of this engineering school. We are part of this engineering school, but the name engineering management implies that there's more to us than simply engineering, and that is true. Actually, we find ourselves right at the juxtaposition of engineering and business. It was recognized over 100 years ago that the engineers that the nation was turning out needed to know more than just their technical skills. And for those of you who have a technical background, who are working in industry and business and government, I think you'd probably agree that there are other skills that one needs, like customer relations and business development and quality and statistics and leadership and ethics and many other topics that we teach. And so for that reason, engineering management as a study area was established a long time ago. So we hold a unique position in that we in some ways bridge the gap between engineering and business. An important thing to remember is that our focus in our program is on engineering. This is a differentiator between us and, let's say, a master's in business administration, where the focus is totally on business. For us, we're about the engineer. We're about the person with the technical background, or someone who is working in a technical field, so that we can help them, give them the skills that they need to move to the next level. And that's probably, for a good percentage of you, if our statistics hold true, that's why you're here today. Your innate skills, what you took with you when you were hired, wherever you're working, have helped you to succeed to the level you're operating at. But perhaps you believe that, I need a little bit more. I want to know this subject area more in depth. I want to understand how to lead better. I want to be a better leader. I want to help my team to achieve higher levels of performance. I want to help my company by being a better member of the company. And so if that's why you're here, that's why you showed up today, that's a good thing, because that's where we're at. All of our professors have a background in engineering, and then they provide you the other skills that are necessary to excel, listen to this, excel past your contemporaries. We're not just providing you an education. We want you to leave this program, should you decide to join us, and excel past your contemporaries. That's why we're here. Why engineering management? I think I may have touched on this already. We do bridge the gap between, as I said, between business and engineering. But here's something else. Leadership. The skills that we teach here, from Wendy's quality management classes to our classes that focus directly on leadership are designed to help you take over a team and to lead it in the way it was meant to be led. Across the nation, across all industries, in my humble opinion, there is a dearth of great leadership. When you leave this program, we want you to be the best leader and manager that you can be. The testimonials that we get from our graduates tell us that our program is succeeding. And we keep up with our alumni to understand what business and industry are requiring so that we modify our courses and our techniques to make them make you ready to excel whenever you get to where you're going. So that's why engineering management is important. It's not enough, and this is an important principle behind our program. It is not enough just to know your technical background. It's not enough just to understand management techniques. It's being able to apply it in a way that is inspiring for the team who is working with you. If you can do that, you can write your own ticket. CU Boulder. We, ladies and gentlemen, have designed our program for the working professional. That is the technology, the teaching techniques, the scheduling, everything is designed for you as a working professional. And I'm assuming that many of the 50 or 60 people who are signed online are in that situation. You're a working professional. You may be asking yourself, how the heck am I going to fit this into my schedule? I have a mortgage, I have a minivan, I have a family, I have children, I have soccer teams, I got all this stuff going on. Yeah, I know it's important for my professional life, but how do I fit it in? Well, that's where we come in. And that's why engineering management at CU Boulder is designed for you and the working professional. We have 3 different ways that one can participate in class. One is live in the classroom if you happen to be lucky enough to be here in sunny Boulder, Colorado. The second way is to participate live in class electronically. You can sit at your desk in New York City, sign in, and participate live in our classes. I have one gentleman who is part of the UN force in Sudan. And I have absolutely no idea how he signs in, but he does. And it's 2 o'clock in the morning where he signs in. It's 5:30 where we are. And by golly, if he doesn't sign in every night and attend class that way. Third, we record all of our class presentations. And they are available for you within 24 hours after the class is given. And you can sign on to that and watch the classes at your convenience. After dinner is over, after work day is over, on the weekends, whatever time is convenient for you. It's designed for the working professional. Our course content, you're going to love it. We have a breadth and depth of courses to round out one's education to prepare you for leadership and management wherever you may work. And our faculty, as I said, they bring real-world experience into the classroom every single class. I wish I could go back through this program again. In fact, I got to tell you, when I graduated from CU in 2000 with a doctorate in aerospace engineering, I figured I had the world by the tail. And everyone was going to want me for who I was and what I knew. Wasn't true. When I first checked in at my first job in industry after finishing my doctorate, everything that I'd studied in my technical field really didn't matter. The important topics were the ones that we teach in this program. And honestly, I wish I'd had the opportunity to take it when I went through school here. Why are you here? I think all of these reasons matter, and you may find your reason on this slide. I would tell you, though, that our hope is that you will be part of a new cadre, a new core of people leaving our program and improving business, industry, and government across the nation, wherever you end up. This is a testimonial from one of our recent graduates. I'd point out one word in her testimony, and that is positive. All of our professors support the idea of a positive work environment for your employees as a leader, a positive leadership climate to help them have the opportunity to spread their wings and become who they were meant to be. And so that is one of the intents behind what we teach here. Graduate programs, we offer a master's in engineering and engineering management. We conduct dual degrees with many departments here in the College of Engineering, and we offer a variety of certificates, taking 4 courses in order to complete a certificate. The master's requires 10 courses or 30 credit hours, and we can talk more about that in detail at the end of our presentation. But this idea of having both certificates and a master's degree has provided a great amount of flexibility to many of you who either have a little bit of time to pursue a certificate or a lot of time to pursue a degree. So I'm going to turn the desk over to Professor Wendy Bailey, and she is going to provide an introduction to quality management. It's an opportunity for you to see the kind of teaching that we have here and one of the topic areas that we teach. Good.
Thank you, Dr. Moore. Well, welcome everyone. So glad that you joined us today to talk about quality management. I thought I'd give you a little bit of background on myself. I have a degree in mechanical engineering for my undergraduate degree, and from Purdue a little while ago. And I also got my master's of engineering in engineering management here at the University of Colorado at Boulder. And I went through the Master Black Belt program in Six Sigma, actually my second time going through a Master Black Belt program. I also was trained by Luftig and Associates. So I've really enjoyed my education here. I took the whole program online, so if you have any questions about that and how that works, I have to say it worked really well for my life, and having a young child, it was fantastic. And also I got to join a great group of individuals here. The professors here are fantastic. I absolutely love working with my peers. Just professionally, give you a little bit of background, I worked for a wholly owned subsidiary of Anheuser-Busch called Metal Container Corporation, and we made cans for Anheuser-Busch, but also for Pepsi and Coca-Cola. I started off as a lid process engineer, helping to design experiments and design equipment to make lids, aluminum lids, and then moved out into manufacturing, where I was statistical quality control manager. I was an engineering manager along with being statistical quality control manager, and then also managed all aspects of quality for the organization. So we're going to talk a little bit today about quality. This is an introduction to quality. I'm going to cover an introduction to quality, quality myths, and some principles, and then we'll talk about quality management and the program here at CU. So first of all, I want to ask you a question, and that question is, what is the purpose of business? And I want you to think about that for a second. What is the purpose of business? I know when I think about that question, the first thing I think about is, of course, it's to make money, right? But I want to propose something perhaps different, a new perspective, because it's possible that the purpose of business is really to make lives better for people. Where we come together as a group and we do things as a group, as an organization, that we could not do if we were to do it by ourselves. And there's lots of people who are involved with that organization. There's the customers, there's employees of that organization, there's other stakeholders, owners, suppliers, and really it affects the whole community. So business is not just about making money. It can be more than that. That's an important part of it, of course, profitability. So the main concerns of business really include things as, if you want to have a successful business, it includes things such as value, revenue coming into the organization, how much market share you have, growth in your organization or business, overall profitability. But the things that remain imperatives always to any business include quality, productivity, and cost. So why quality? Why do we even consider quality in business? Higher quality enables businesses to do different things that they would not be able to do. These things, cost, productivity, market share, they're all directly related to quality. So quality helps us to reduce rework, reduce waste in an organization, reduce testing, not having to go back and do the things to a product or service that were supposed to be done the first time. It helps us to increase our productivity, increase yields, reduce overall cost, help increase customer satisfaction, which is going to increase market share and then increase profitability. So lots of good things quality adds to an organization. Now, you may ask yourself, what is quality? And quality can really be viewed from many perspectives. First of all, we can look at it from a transcendent or judgmental perspective. And that is, I know quality when I see it. And many of us do. We might associate quality with a certain brand. When I ask some of my students, I'm like, what is a quality computer? They immediately say, Apple. Okay, so they say a Macintosh or something like that. They associate that as a really popular brand name. Or if it's expensive, like this really cool car in front here, or some other type of brand name. That's one way that people can define quality. Some people define quality as how many features a product may have. And you can see here, some of you may be familiar with The Simpsons. This is the Homer Simpson car, and if you remember, it had lots of extra features on it. More features for some folks means higher quality. There's the user perspective, the practical perspective, which is it's useful for what I intend to use it for, or how well it performs its intended function. We have a picture of one of the quality gurus, Joseph Durand, who was instrumental in helping turn around the economy in Japan, along with W. Edwards Deming. And he said that quality is fitness for use. And then we have some other perspectives, such as quality versus price, which is really the value perspective, and that's how the consumer makes the purchase. That's what influences a consumer to make a purchase. How much value do I get from buying this product or buying this service? And then there's the manufacturing perspective. How well does it conform to specifications, which really is a myth. And we're going to talk about that here very shortly. It should be, how well does the product characteristic or service characteristic or process characteristic conform to a customer-defined nominal or target? So let's talk about some quality myths and principles that are still prevalent today in business. So if you're asking yourself, why is it that high-quality products and services are so challenging to achieve? I'm going to talk to you about why they are. We're going to cover 4 myths about quality and then 3 principles of quality. First, let's talk about quality myth number 1. Here it is. Any part inside specification limits is good, and any part outside the specification limits is bad. Now, I don't know if I have my pen up here. I don't think I do. That's okay. So let me ask you a question. If I have a part that's made here, the pen's over here, okay. Oh, there it is, okay. Here we go. Let's say that I'm going to change this color here. Let's say that I make a part, and I make this part right here. You would all say that that is good. Okay, it's in the green, it's good. Okay, let's say I make another part here. You would say that that is bad. Okay, what if I make another part and it's right here? It's good. Okay, what if I make another part here? It's bad. Oh wait, I'm going to make another part here. It's good, and I make another part here. What if I make one right here? What if these were consecutive samples? I couldn't, this over maybe a 24-hour period, and I made a frequency distribution. It turned out that this is what I was making. What would this tell me right here? This would tell me that I'm making approximately 50% out of specification. Now, if this is all you were making, maybe that's not a big deal. But if you were in the can industry and you're making 6 million cans a day, this is a big deal. Okay, so this is a fallacy, and this is still very prevalent in industry today, that in spec versus out of spec is a good way to manage product and process performance. Myth number one. Myth number two is this: any parts falling within specification are equal in quality, cost to purchase or manufacture, or cost to use as part of a greater product. And as a result, quality is conformance to specification, which we already dispelled that myth in myth number one. So let me tell you a story about, these were Sony TVs. And back in the day, there used to be a picture color tube in the television set. TVs weren't as cool as they are today. There weren't flat screens, and in fact, they were these big, gosh, they maybe stood up this far in the back, and there was a color tube in the back that would determine what the color density on your screen would look like. There were warranty issues with these Sony TVs, and that particular color tube, one of the critical characteristics was color density, and they had two locations where they made the picture tube. This is what the distributions look like. First, there was Sony in San Diego. This is what their distribution of color density looked like between the lower specification limit and the upper specification limit. This is what the distribution of color picture tubes look like from Tokyo. Now you can see those distributions are very different. The red distribution is what I would call a uniform distribution, and it's indicative of using up the entire specification range. The one in the middle by Tokyo is normal distribution, and you can see it's more centered around target. Now, there would be no way that the consumer would know which location made the picture tube. And it turns out the place that had the most warranty issues was not from Tokyo, but it was from San Diego, because they were using that whole specification range. Now, with a warranty issue, you have to return the product. And if this is truly the distribution from here to here, they're going to replace that picture tube with something from the same distribution, and it's going to cost again and again and again. So they're not equal in cost. And that leads us to a concept developed by an engineer from Japan named Genichi Taguchi. He developed something called the Taguchi loss function. And what he said is that as a product characteristic deviates from its nominal or design target, its ideal design target, the loss to society, or we would say the loss to a business, increases. And so mathematically, it looks like a quadratic equation. And you can see here that we associate that as we move away from that target, that loss increases. So with a uniform distribution like this, when we use the whole specification range, the loss to the company or to society, if you wanted to take it a step further, increases significantly. You can see the losses associated with the Sony picture tubes were a lot less. So the first principle I want to bring up is that the reduction of variation lowers your total cost and increases productivity, and that results in the reduction of loss to the organization. So a key concept here with quality is that it is about reducing variation. Reducing variation. Okay, the next one, let's say we reduce variation. We're conforming around an appropriate target. A myth around this is that an operation which attempts to manufacture to conformance can accomplish its goal. So perhaps I'm centered around the target. However, I'm just minimally capable. I'm not working to continuously reduce variation. Now, if I'm just right here, what happens if my distribution moves because of some external source of variation? I'm now making something out of specification that's non-conforming. And I would say that sometimes shift happens. So that leads us to principle number 2. The goal of the quality effort is conformance to nominal or target, not simply just conformance to specification limits. We're trying to conform to the ideal target, ideal design target that we determine from customer information. So reducing variation is really the goal of the quality objective. So you could start off with something like this, but ideally you want to move towards centering around an appropriate target and continuously reducing variation and thereby reducing loss to the organization. Now, we're going to do something fun. Quality myth number 4, our last myth. A manufacturing operation that produces defective products can manage not to ship bad parts to its customers. Let's do a test. I bet you're wondering, how effective is 100% inspection? So I'm going to train you. You will be an inspector, and we have a paragraph corporation. I'm going to have you inspect this paragraph for the letter F. So it could be a letter, capital letter F or a lowercase letter f. I'm going to give you 90 whole seconds to do this. And what I'd like you to do is, after you have counted all the F's, I'd like you to type in your answer. I'm going to type in your answer into Zoom, and then I'll have the folks in the back give me your answers, and we'll see if you get the correct one. So you get 90 whole seconds, so there's going to be an awkward pause here for 90 whole seconds, but I'll count it down for you. Are you ready? Okay, 1.5 minutes. Here we go. On your mark, get set, and go. Nope, keep going. If you've counted them once, you can count again just to make sure. Okay, you're at 1 minute, 30 more seconds. Okay, 5 more seconds. And time. All right, what did we get? Getting numbers?
See the result in the chat.
Oh, no, I can't see the results in the chat. I was going to have you guys read it to me in the back.
I told the range. Yeah. 40, 42, 46, 37, 45, 42, 43, 33,
Oh, my goodness.
36,
36,
35,
35,
44.
44. Okay, I think that's a good sample. Why don't we all get the same number? Okay, I know you want to know what the answer is, so here it is. It's 48. That's the correct answer. Now, some of you may be asking, why didn't we all get the same number? Well, it turns out that visual inspection for humans is not very powerful. It's about 85% effective. Even with machines, it is not 100% effective. And a lot of people today use visual inspection as their main source of controlling quality after they make a product or after they produce some type of service, which leads us to principle number 3 is if you're making it, you're shipping it. The only proven method for shipping product 100% within specification is 100% of the time you have to make it that way in the first place. So where a lot of companies start is with what I call the product control cycle, where we go through we have an input, process, output, we make something, then we sample the output, we look at the product, and then if it's good, we ship it. If it's bad, it goes into a pile and we either rework it or we throw it away, which is an expensive way to run a business. What we try to do with what we teach here in our program here at CU Boulder is teach how do we move from the product control cycle up to maybe a first phase process control cycle where I'm looking at the process that makes this output, whether it be a product or service. I measure that, I perform some type of analysis and make adjustment to the process itself before it gets to this point. And I use predictive methods to make sure that whatever I produce here is where I want it to be. And then ideally, I want to move it up even further to look at both the process and perhaps even the inputs to the process and understand what is the relationship between the inputs and the outputs so that I can control things up here and get everything going on up here, because variability that goes into this part of the process is going to manifest itself as variability in the output of the process. So it's kind of like this. In Colorado, we have a lot of great places to go camping. Fantastic places, beautiful vistas. It's a little cold at night, so you have to bring some warm stuff. But let's say you are going to go camping, and you set up your tent. You've got a nice fire going. You're by the trees. There's a beautiful river running through close to where you've put your campsite. And you taste the water, and you notice an off note to the flavor because you needed to fill up your canteen. Now, you could go in and start performing some type of experiments. What you may not know is that upstream in this river, there's a beaver. And the beaver also likes to swim in the river, which is really typical of beavers and Colorado, okay? Now, I could, as an engineering manager or quality manager, go in, I could do a full factorial model, I could sample all these different places and figure out where is the best place for me to taste this water. Or I could just move upstream and sample from here. Now, just as a disclaimer, don't drink any water without treating it first, because always assume that this is going on. I just want to make sure that's really clear and that I'm not telling anyone to drink out of the stream. Don't do that. So that's from the manufacturing perspective. We've covered some of the myths and principles associated with quality. There's also a customer perspective, and really what we're trying to do when we create a product or process or service is meet or exceed the customer expectations. They have needs, we want to meet those, and we want to make that exchange of money. So if we want to take all of those perspectives and combine them together, this is the true definition of quality, which is the ongoing reduction of variation around a customer-defined nominal, and that word nominal means the ideal target in the absence of defects. And that's what quality is. It's all about reducing variation around the right targets and meeting the needs of a customer. Now, there's two aspects of quality, if you want to just simply divide it into two. First of all, there's design quality, and that's knowing what the right specifications are, what the right targets are, so that we can meet and exceed the needs and expectations of a customer. But there's also conformance quality. Once you know what that design target is, how well or how consistently can you meet that target day in and day out? And I liken it to hamburgers, which is one of my favorite foods. And I apologize if beef is not one of your things. You can put in salad here. But I really like good hamburger. Okay, but design quality and conformance quality are different. If I think of McDonald's, and I go to McDonald's, and I'm not saying McDonald's is the best place to get a hamburger. If I go to McDonald's in Fort Collins versus McDonald's in Boulder or McDonald's in New York, I pretty much know what I'm going to get when I get the burger off of the dollar menu. They're really good. McDonald's is really good at conformance quality. They have a recipe, they stick to it, and it pretty much stays the same anywhere that you go within the United States. Maybe different overseas. But with respect to design quality, perhaps this is not the ideal hamburger for all customers. Other customers may have some different ideas about what their needs and expectations are with respect to an ideal hamburger. And we have to know what those are in order to meet those needs. So achieving high quality doesn't happen by accident. It's very purposeful. You may be asking, how do we implement these principles? And that's where our program comes into play with quality management and quality science. So what is quality management? Quality management consists of the systems, strategies, and tools used to manage for quality in organization. So it includes a management system, which is basically the way that the organization manages its business processes. It includes strategies, which are techniques within that system that typically are used to address some type of issue. Perhaps it's improving performance, or perhaps it is reducing failures, reducing variability, or doing some advanced quality planning in order to design a product or service appropriately. And then the last part is tools that are used within the strategy, which are basically applications employed to generate knowledge or understanding. And those are the things that we cover in our program here at CU. So in addition to leading and managing people, engineering managers, I think, are unique in that they also manage things that are inanimate. They may be moving, but they're machines or processes or programs, other things like that. So things that they're involved with include making decisions about design of a product, designing a process to make that product, or designing a service. Making decisions and solving problems is a big part of the engineering management position. And then also analyzing data, because data is the way that those objects, processes, machines actually talk to us because they don't have a voice. Their voice is the data that we collect from them. And all of these activities here directly affect quality. So with our courses, we basically have two sections. I like to say that they're partners. These two are partners. They go together. And it covers the quality sciences and research methods. Most of these classes are more quantitative in nature, although I just gave you a presentation that's more qualitative. We do use some mathematics in these. We talk about, in the quality science area, we talk about things such as different strategies that we might use to improve in business, which would include total asset utilization. We would talk about customer quality assurance, strategic planning, supplier quality assurance. We also talk about, and methods for quality improvement, ways to look at the stability or manage quality through time of a product, statistical process control, process capability, measurement system analysis. And then we have advanced topics in quality systems and engineering, where we cover all of the strategies you might use to improve a product or to design a product or service. And of course, this is married along with the statistics arm, which is the research methods. Everyone who wants to take a quality science course will first take this Introduction to Applied Statistical Methods. Fantastic class where you learn the basics. Then we move into research methods and experimental design, which it covers all types of analysis of variance. And then the advanced statistical methods or engineering research covers analysis of variance for more than 2 different factors. And then the last part here is data mining and screening experiments for engineering research, which really ties in with the Design for Six Sigma advanced quality planning part. And it's pretty cool. This is one class that I really, really wish I had had when I was practicing engineer. So those are the courses that we teach. Let me tell you, I'm sure some of you are on here because you're interested in the BELT certifications, and we do have those here. They are offered in partnership with the ROI Alliance, which is our industry partner. So for a green belt, these are the courses that you would take. There's 4 courses for the green belt listed here, which I just covered on the previous slide. If you are interested in a black belt program, you would take the green belt courses along with 2 other courses which are listed here. The Advanced Statistical Methods for Engineering Research and the Data Mining and Screening Experiments. And then Master Black Belt, you'll add a couple more topics. The Advanced Topics in Value Creation, which is one of my classes, and a leadership class, which is leading yourself, which is the first step before you lead others. And I believe that is the end of what I have for a presentation today. We do have everyone here who's on our admissions team, as well as myself and Dr. Moore, and we're happy to entertain questions at this time. I'm going to move over here and let's see if we can pull up the questions here.
So ladies and gentlemen who are viewing the webinar, Wendy and I have gathered together some questions from the last time that this webinar was run, and we'll review some of those. They may be thought provokers for you and questions that you may have, but our purpose for the last 10, 11 minutes here is to simply answer questions that you may have, and we'll take it from there.
Okay,
So Wendy, do you have the?
I do. I'm going to pull this up here.
Okay. All right. Very good.
I think. Well,
It's all right. Take your time. Good.
here's some chat. Okay. First question here, it says, can I do a certificate as an exchange student who is staying at CU Boulder for a fall-spring term?
Okay, read that again so we can get a handle on that.
It says, can I do a certificate as an exchange student who is staying at CU Boulder for a fall-spring term?
Kendra, your thoughts on that?
It would depend on, visa, things like that, so we could take that offline if they want to send me an
Okay.
email.
Okay.
So visa is a consideration, and how long was the person staying? 1 semester?
Looks like 1 year.
1 year.
Yes.
So one of the questions I would say, and Kendra, Ms. Tebow, whose picture was on the screen just a moment ago, is our graduate advisor and can certainly help you with that. But I think we can provide a general question right now. If one is here for 1 year, I'm assuming that means 3 semesters, which would be fall, spring, and summer. And so if 4 courses are required for a certificate, then 2 of those semesters would have 1 course and 1 semester would have 2 courses. And that, frankly, that's not too heavy a load. Especially if you're working at the same time that you're here. So Kendra also mentioned there might be visa considerations. And so if that's true, then we would want to make sure that everything is lined up properly. Kendra has years of experience working with students with all kinds of situations, so I'm sure she could answer your question specifically, but that's a quick overview of an answer. So who do we have next?
The next question is, I see, Kendra, you answered the question on fall or spring term. And so we have fall and spring admissions for those who are interested in joining us. We have both of those. Another question here, and this is from...
Let me add something real quick. By the way, as a side note, one of the things that we've been wrestling with recently is the amount of growth that we've been seeing. Our undergraduate program has grown incredibly. The graduate program is expanding, and we're actually in the process of creating new courses to help manage that growth. So if you decide to give this a try, you're joining a program that is in the process of growing considerably. Please.
A question from Sean is, can you summarize the range of timelines to complete the EMP program, whether the student is full-time or completing as a working professional?
Okay.
So I know what's reasonable, what I think is reasonable, having been a student myself and working full-time, would be 1 to 2 courses per semester. And I think it took me 3.5 years as a working professional to finish my coursework. And it really depended. There were some semesters where I knew the class was going to be more challenging.
And then you back down to 1 course.
Back down to 1 course so I
Right.
could focus on that 1 course.
Right.
So yes, you can get it done 3.5 years. I know some students who do it full-time, and Kendra, you can probably help me with this one, but some will take 3 to 4 classes a semester.
That's usually if they're working part-time or
Okay.
not working.
Or not, yes, if they're not working, they'll do 3 to 4. I've had some students who are doing full-time and taking 4 classes. That's a lot. It's a lot. I wouldn't recommend more than, if you were doing this, more than 3.
Agreed.
It takes it's a lot of work.
We've had some students get through in a year. For example, students who are working with the Department of Defense and the military has given them just 12 months to get it done, then they load it up as much as possible. But those are the exception rather than the rule. I think, Wendy, how do you tell if the load is too much? How do you know whether to take 1 course or 2 courses? Is it based on how much hair one loses when you're pulling it out? Oh my gosh! Or what's the driver there?
I looked, you can either talk to a professor to ask what the weekly, hourly assignments might be, and so some of the courses might be heavier than others. There's also, you can look that up on the FCQs. So perhaps some courses you might have 15 hours of work per week, including watching the class. Others maybe 4 to 6. So I use that. You can look that up online.
Right.
Through the faculty course questionnaire, and the students will give their assessment of how much time they spent on the course. And so that's one tool that I use to help plan, in addition to talking to the professor.
And so you mentioned looking at FCQs. Those are faculty student questionnaires.
Yes.
And so the university keeps a record of those online, and that can give you an idea how much work is.
Right.
The students
right.
actually are grading the courses. And so the students, and it's kind of like a blog, and so you can look on there and get ideas of how much work is required and things like that.
Right.
You can also take a look at which professors you want to.
You can.
Yeah, which professors are exciting and which professors, yeah.
Yeah,
So-
I'm not sure that excitement is a rating category. I'm super exciting, so.
So am I.
Another question
golly.
here, is work experience mandatory to take this course?
Good question.
And that is a really good question.
Good question. Is work experience required? And you may see work experience as a phrase on our website. Work experience is not a requirement nowadays. However, we recommend it. This is graduate level education. It is focused on people with a technical background, and the direction we're headed in our courses is business. And so if you have some work experience that you can relate to, then that makes the courses that much more meaningful. It's like talking about rock climbing. We're on Colorado kick.
Yeah.
It's like talking about rock climbing. If you've experienced rock climbing, then what the teacher is talking about is that much more, that much more applicable. But it is not required. And we have many students in our classes who do not have that work experience, and they do just fine. Would you say that's fair?
I think it's very fair.
Good. Okay. Who do we have next?
Does a degree on pharmaceutical chemistry apply to this? Absolutely.
You mean in terms of a technical background?
Absolutely.
Yes, I would agree. I would agree. So, yeah. And we do maintain a course for those people who do not have a technical background. And we, for one semester, we help them to understand the principles of engineering that are the basis for our courses. But if one has a background in that area, then that course would not be required. It certainly provides a sufficient background in science, if you will, that would give you a foundation for some of the discussions we have on engineering. You think?
Yes,
Okay.
that's good.
All right.
Kendra, I'll probably need your help on this one. What are the prerequisites to take this course for someone who has done their bachelor's in India?
So there aren't any prerequisite courses, but there are potentially some international requirements for admissions.
Right, so TOEFL, is that one that would be a
It
requirement?
is not required at this time for
Okay.
Indian
Okay,
students. So.
Okay, we might want to repeat that since I don't know that Kendra's mic is on.
Oh, yeah.
so there's no particular prereqs that are required for, if you got your bachelor's degree from India, but there might be some, for an international student, there might be some additional requirements. Do you know exactly what those are, or is that something that they can?
I can provide the link.
Okay, so Kendra will provide the link to that through the chat system, correct?
Yes.
Okay.
This question here is from Greg. He says, how long would it take to complete a certificate in engineering management? I would say our typical certificates are 4 courses.
Yes.
And so depending on when you start the certificate, it could take anywhere from 1 year to 2 years, depending on what certificate it is.
If you're taking one course per term, how long would that
Course
take?
per term would be 2 years.
Be one, if you took during the summer, could you shorten that?
You could definitely shorten it.
Okay, so because we do offer summer courses, not all of our courses are offered during the summer, but many of them are, our graduate courses. And so if one of the required courses were taking place during the summer, you could do it during the summer term, and that would shorten the time period. But Wendy is right, fall, spring, 2 fall, spring terms would cover 4 courses, and there you go, you're done. Good question.
That's a good question. Next question is from Brandon. It says, how much interaction do you have with other engineering departments? Are these courses process engineering focused, for example, environmental and civil engineering?
Yeah, that's a good one. So our relationship with several of the departments, you may have seen civil engineering, you mentioned civil, on one of my slides during the first part of the presentation. And yes, those departments like what we have. I'll just put it that way. In particular, an example, not civil, but engineering, aerospace engineering. Aerospace engineering students flock to our systems engineering class because it's not offered anywhere else in the college, and because industry loves engineers to show up with a background in systems engineering. So that's an example. I don't know if I answered that full question. What was the...
Well, the question was, how much interactions do you have with other engineering departments?
Yeah, so...
Of course, it's process engineering focused.
Right, right. So we find that the departments like to focus on what they do best. I gave an example of aerospace. Aerospace wants to focus on everything from designing of airfoils to orbital mechanics. Systems engineering is a process-oriented course and would fit best in engineering management, and so we teach that. So the same thing is true in our conversations with civil engineering. I met with the department chair of civil engineering just the other day. We were talking about the engineering management communication course. We call it engineering communication. And they want to send a cohort of their graduate students to our engineering communication course this summer. So yeah, the collaboration is hand in hand. Good. Do we have time for, how are we doing on time?
We have time.
Okay,
Okay.
let's take 2 more questions here. How's this, Amy? Will there be another introduction session to the Six Sigma program?
Potentially.
Potentially. I'm ready.
Oh, you mean
This is for Max.
Max?
Max, if you're a math person,
Yeah.
just come on.
We will let them know if there is.
We'll let you know, for sure. I'd love to do that.
There you go.
The next question is, how does the coursework pertain to consultants providing a service? For example, heavy civil design and construction services.
And so your question, I'm going to try and see if I can paraphrase that. Your question is, if one is a consultant, how would our courses relate to their work?
Right, for civil design and construction, that field.
You know, that's an interesting question. The consultant's job is very challenging, at least from my opinion. And so the question is, what skills does one need there? So let me you can certainly take a look at the website and take a look at the courses that we have and whether those would be helpful to you. I would say, though, that and this is, again, my opinion, but it's my opinion having an incredibly varied background from industry to as an engineer to science to academia and to military. And I've also run 2 small businesses. And so the courses that we teach are broad enough in nature where the skills that one learns from leadership to quality to entrepreneurship and entrepreneurship have general application over an incredibly broad range of work areas. And so my general answer to your question is yes. However, should you have specific sub-questions related to this, I would be happy to discuss it with you on the phone. And with Kendra's contact information, we can set up a time. I'll be happy to discuss it with you, specifically from a consultant's point of view. We do have some of our faculty and former faculty who work as consultants, and they might be able to better answer your question. What did we say, one more?
We could do one more. Do you accept credit hours from master level courses at other institutions?
I just sent it.
Oh, you did? Okay.
What's the answer to that question?
We would need to know what the courses are.
Right. And Kendra, do we have a limit on number of courses we'll accept?
Yeah, we could just have a discussion offline about transfer credit.
Okay.
Okay. All right. Very good. Discussion offline. What else? Is there one more?
Yes, let's do one more. This is from Sean. If you complete the Master's of Engineering degree while taking classes that satisfy the requirements for any of the certificates, can you receive a or any certificates in addition to the master's degree? Is this common, or is it difficult to add 1 to 2 classes to get an additional certificate?
Certificates in addition to the master's degree.
So you're allowed to get 1 certificate, and then you could do the belt certification.
Okay, so you can have one certificate
With
plus the industry certification, which is for Six Sigma.
So you have your master's degree, okay, then you have 1 certificate that you can have with that.
Right.
And then you can,
Also get a black belt certificate or master
Which
black
is
belt
what you did.
with green belt or green belt. Is that correct?
Yeah, and that's
Okay.
what you did, correct?
Yes. Yeah, I guess I did do that.
good. Okay. All right. Do we have more questions coming in? Are there more coming
I
in?
think that's all we have for now.
That's it?
Yes.
All right. Well, good. I think then it's a couple minutes after noon Mountain Time, and so Wendy and I and our team here are going to sign off. We hope you enjoyed the adventure we were on today. Should you have other questions, Kendra, and by the way, can we put Kendra's contact information back on the screen? Do we have that, and can John put it up there before we sign off? Because we've referenced her several times. And John, can you turn the screen on again with that information?
I could also type it in here,
Okay,
I think.
all right,
Maybe not.
okay, very good. We may be, I don't know if we have the ability to show that slide again. But anyway,
Okay.
let me just say, I don't know if we have the ability to send that out to everyone. Amy, can we do that? Okay, so that'll be good. We'll send that out. And Kendra is I got to tell you, and if you're interested in finding out more about the program, Kendra has most of the answers. If she doesn't, we'll get you an answer to what you're looking for. Again, the program is designed to be flexible. It's designed to fit into your busy life as a working professional. But I got to tell you, it's a good ride. The faculty members here are all just as great as Wendy is in teaching, and it's a fun ride. So we look forward to talking with you. Those of you who have further questions, I don't know if we'll be running another webinar at some point in the future. Amy is telling us that we will. We'll look forward to that. I'll have a chance to chat with you again. And by golly, if you have a chance, get away from that bomb cyclone and come on out here to Colorado.
Do it.
Ride a horse. Yes. And enjoy the sunshine. All right, been our pleasure. Thanks so much. Have a good day.